Section 2.6 is something we're going to be coming back to over and over and over again throughout this year. So we start with a basic introduction of how it works, and then we'll revisit it in several different chapters later on as we progress through chemistry. But our aim for Section 2.6 is to learn how dimensional analysis can be used to solve various types of problems. Some of you may have seen this before. It's got different names. You may have also heard of this as the factor label method. So it's a specific type of procedure for solving conversion problems in chemistry. And we do a lot of conversions. As we get going, you'll see that we do multi-step problems in one-dimensional analysis problem. And this is very helpful for determining how our units will end up canceling as a result of all of these different conversion factors in one problem. Dimensional analysis follows a series of steps. So I'm going to introduce the steps to you first, and then we'll go through each one at a time and take a look at what each of those individual steps looks like and how we can apply them to an overall larger problem. The first step is that when you're converting, you're going to use an equivalent statement. And we talked briefly about equivalent statements before, and there was even one I asked you to remember, but we're going to be looking at those again. Step number 2 is to choose an appropriate conversion factor. You need to do step 1 before you do step 2. The conversion factor comes from the equivalent statement. So we need to make sure we have the correct equivalent statement, and then we're changing that into a conversion factor. Step number 3 is to multiply by that conversion factor. Essentially, dimensional analysis is a series of multiplication problems, and we'll look at all of the different ways we can put those into a calculator, and you can choose the method that works best for you. The next step is to check sig figs. So we need to make sure that we're representing our measurement accurately, and that's why we use sig figs in the first place. So we need to make sure that our answers reflect the appropriate number of sig figs that should be in that problem. And then finally, we have to ask ourselves, does it make sense? If we're doing these problems and we get an answer and we say, well, that's not quite right, we know we probably did something in the problem. But we have to use our history and our experience and things we already know about to answer the question, does it make sense? Starting with number 1 and the equivalent statement. So an equation relating the same quantities in different units. And there are a lot of these out there, and we talked about several of them when we were converting back and forth between metric units. For example, 1 dozen eggs, we know just by our own experience that 1 dozen eggs is equal to 12 eggs. We know that every equivalent statement yields exactly 2 conversion factors. So the first one might look like this. We can say 1 dozen eggs, 12 eggs, or we can say 12 eggs over 1 dozen, or 1 dozen eggs. Now, we know that if we're looking at these in terms of a fraction, they don't necessarily mean the same thing. One of them means 1 over 12, the other one means 12 over 1. But which one we use is going to depend on what we're starting with in the first place. Sometimes we might have to divide to get into the right unit, sometimes we might have to multiply. And depending on what we have to do is going to determine which of these equivalent statements we're going to use, or which of these conversion factors we're going to use. Conversion factors are used in dimensional analysis to allow conversions from one unit to another. So we're going to take that equivalent statement, and now we're going to turn it into a conversion factor. So which one is correct? These are 2 different ways of expressing the same equivalent statement. Do they both mean the same thing? Not if we're looking at them individually, but if we're looking at them in the context of a larger problem, in a dimensional analysis problem, both could be correct depending on what our problem is asking us to do. For example, if I want to calculate the number of eggs in 2 dozen eggs, you could probably use your experience and background to tell you that 2 dozen eggs has 24 eggs. But let's check our method using that experience. So I have 2 available conversion factors that come from my 1 equivalent statement that I know is 1 dozen, equals 12 eggs. I know this. We've already defined 1 dozen as 12. So now I need to figure out which one is more appropriate to use. So in this case, we need to know which one is correct by starting with our given piece of information. And our given piece of information is 2.0 dozen. That's the number that I'm starting with. Now, in a conversion problem or dimensional analysis problem, your step number 3 is to multiply by a conversion factor. So we need to choose which one of these conversion factors is more appropriate. Remember, the point here is that you want to be able to cancel out units of, in this case, dozen, and end up in units of eggs. So we need to figure out how we can cancel out the unit of a dozen. We need to draw a line. And in dimensional analysis problems, that line reminds us something has to go on the top and something has to go on the bottom. And if we follow these same steps every single time, it's pretty easy to set up a problem in this way. So which conversion factor is more appropriate? It's going to be the one that puts dozen on the bottom, because we know when I divide the unit by itself, I get 1 and the unit goes away. When we're matching that up, we're just matching up the number with the unit we've already identified that goes on the bottom. So I'm putting 1 dozen on the bottom. And what's going to go on top? 12 eggs. So we can see that in this case, this specific conversion factor was more appropriate for how we're setting up this problem. Like I said, the setting up the problem helps you see which units you're able to cancel. We know we don't want to end up in dozen because I want to convert that to eggs. So we can see in this problem, we have canceled out the units that are dozens. So when I do this math, I'm going to look at it as multiplying across the top and dividing by the bottom. So we know that 2 times 12 is 24. So those dozen units do cancel. And finally, we have to remember that we have to put our unit on the end of our answer. Numbers mean nothing without their units in a problem like this. So therefore, our final unit is eggs. Our last step is to check sig figs. So how many sig figs are in this problem? We can see that we have maybe 2 here and 1 here and 2 here. However, we do have to remember that the sig figs in a conversion factor don't matter, because remember, they are considered to be exact numbers followed by an infinite number of sig figs. So we never count the sig figs in a conversion factor as determining how many should be in our answer. We're only going to look at the number we started with. And the number we started with was 2.0 dozen. Therefore, I'm going to have 2 sig figs in my answer. Do I have 2 sig figs in my answer? Yes. So 24 is the correct numerical answer here. And does it make sense? We already said in the beginning that we were using our experience to tell us that if we had 2 dozen eggs, we knew that that would be 24. So yes, this answer does make sense in this case. In our next conversion problem, we want to know how many centimeters are in 7.00 inches. So we're going to start with our equivalent statement. Step 1 is our equivalent statement. And as you get better at these, you don't have to list out your steps each time. This is just a helpful way to do it in the beginning while you're still learning how to do these types of problems. But I don't need to see each step every single time you approach one of these problems. The equivalent statement you're going to use here is one that relates centimeters to inches. And we've been using this one. We know that 1 inch equals 2.54 centimeters. We know that when we're coming up with a conversion factor, every equivalent statement yields 2 conversion factors. The first one is going to be 1 inch over 2.54 centimeters. And the second one is the inverse of that, 2.54 centimeters over 1 inch. So what do we do with this information? We need to multiply by the appropriate conversion factor. So we need to figure out which conversion factor we're going to use. And that's determined by what piece of information we start with. We were told we want to figure out the number of centimeters in 7 inches. So we're going to start with 7 inches. Our first step is always to draw our line. Remember, that line just reminds us something goes on the top and something goes on the bottom. What's going to go on the bottom in this case is just the unit. We want to make sure that the units will cancel. Students tend to rush into putting numbers by the unit, and they usually end up doing that the wrong way. If we start by just putting the unit on the bottom, then we can refer back to our equivalent statement, which is 1 inch equals 2.54 centimeters. And now we can make sure we put the appropriate number with the appropriate unit. We know that 1 goes with inches and 2.54 goes with centimeters. So 2.54 centimeters over 1 inch is the correct conversion factor. Now we can write our equal sign because we can see we got to the unit we were looking to find, which was centimeters. Now if we put this in the calculator, we get 17.78 centimeters. We need to make sure that our units cancel. Inches on the top, inches on the bottom means that inches gets canceled out. I'm left with units of centimeters. So I know I did something correctly here. We want to check sig figs. So if I'm checking sig figs, I want to round to 3. Remember, the number of sig figs in my conversion factor don't matter. So I don't care what those are. I'm not even going to look at them. What I do care about is the number that I started with. The number that I started with has 3 sig figs. So that's what I'm going to use to determine the number of sig figs in my answer. So if I'm rounding this number to 3, remember I'm going to cut it off right here, and I'm going to round what I'm cutting off, which is the 7, by the number that gets cut off after that, which is the 8. So 8 is greater than 5, so it rounds the 7 up, which is how I ended up with 17.8. Is this the correct answer? Almost. Remember, as I'm transferring my answer from one place to another, I need to make sure that I have the correct unit on my answer. Again, inches canceled, I'm left with units of centimeters. 17.8 centimeters is the correct answer. Does it make sense? We can use what we know about centimeters and inches to even look at a ruler and tell us that, yeah, there's about 17, 18 centimeters in 7 inches. So we can absolutely use something physical, something tangible that we can hold and compare it to make that number make sense for us. Another practice problem, 62 centimeters equals how many inches? We're going to follow the same process. I'm not going to go through it step by step by step. In terms of identifying each step, we're just going to do the problem together. 62 centimeters, we're going to multiply that by a conversion factor, so we draw our line. What's going to go on the bottom is centimeters. 2.54 centimeters for 1 inch. We know that comes from the same equivalent statement that we've been using. 1 inch equals 2.54 centimeters. Centimeters cancel because they were on top in the beginning and on the bottom in the second conversion factor. Remember, when we're looking at the number 62, we're also looking at this as 62 over 1. So we can say centimeters was on the top of the first conversion factor and it's on the bottom of the second conversion factor. We can put our equal sign because we know we reached the units we were trying to get to. Inches was being asked of us. We ended up in inches, so we can stop here and calculate our answer. When I put this number in the calculator, I get the number 24.4094488. We know that has too many significant figures, so we have to cut it down to a number that's represented in our problem. We know we need the unit, so we can put it on there before we forget to report our final answer, just to remind us that we need to carry that down with us. When we're putting this in our calculator, there are a few different ways we can do it. We can look at this as just what was on the top, which was the number 62, divided by what's on the bottom. Because remember, when something is on the top and you're multiplying that by a fraction, you can just divide it by what's on the bottom if both of those numbers are 1. So it's everything on the top divided by everything on the bottom, 62 divided by 2.54. We can also look at this as individual fractions. So in this case, we're looking at this as 62 divided by 1 times 1 divided by 2.54. So we're looking at 62 divided by 1, multiplying that by 1 divided by 2.54. And the difference here is we're using parentheses to separate the different division problems. Either way you do this is fine. It has to be what's more comfortable for you. I use the method on the top because the method on the top means I can ignore the ones and I don't need to use parentheses. It just comes out a little bit cleaner. Either way, we put this in the calculator, we get the same answer. I need to represent an answer with 2 sig figs because we can see that the number 62 has 2 sig figs. Remember, we don't pay attention to the sig figs in the conversion factor because they're an infinite number, so we don't even need to look at them. So 2 sig figs is what's guiding my answer. I'm going to cut this answer off at 2 sig figs and round according to the number that I'm cutting off. So I'm cutting off the number 4. That's going to round the 24 back down, or rather keep it the same. So I'm going to end up with 24 inches as my final answer. Could you do these problems in your head? Maybe, if you were comfortable with multiplication or division. However, we're going to start looking at dimensional analysis problems that have multiple conversion factors in them. So it's going to be very difficult to do a 5 or 6 step dimensional analysis problem using just your head, which is why a calculator is a necessity for these types of problems. As an example of this, I'm going to show you how to do one of these very long conversion problems. This is an example of an extension question. Something with this many steps isn't going to be required of you at this point. It's just how we can apply what we know to do a problem like this. If I'm asking you to convert 26.2 miles to kilometers, our problem is going to look something like this. Now, we might know directly how many miles are necessary to convert to kilometers, but we don't know that off the top of our head. We do, however, know how many feet are in a mile, how many inches are in a foot, centimeters in an inch, etc. So this is an easier way to display a problem like this without having to look up the mile to kilometer conversion. This problem can get very messy. We're using 5 different conversion factors here, whereas if we did know the conversion between miles and kilometers, we could do that in one step. Putting this in your calculator can also be messy. Again, I like to use the method of no parentheses. So if you'd like to do it this way, what we're doing is just multiplying everything on the top in parentheses, dividing that by everything on the bottom multiplied together in parentheses. Another way of looking at this problem, and this is my chosen method, is to multiply every time you see something on top, and then to divide every time you see something on the bottom. And this way you don't have to use parentheses. This works well also. Fewer keystrokes are involved in this second type of problem. And in this third problem, this one gets super messy because this third one is looking at each of these as an individual set of fractions. Keep it simple. Use as few parentheses as possible. Method 2, like I said, is the easiest for me, but it's totally up to you which one makes the most sense. Take a minute, pause your video, try these practice problems, come back and resume your video for the answers. For these problems, we need to identify a conversion factor that we're going to use for each one, and we can do that as we go. In the first problem, we need to know that 1 meter equals 1.094 yards. There are other appropriate conversion factors as well. It's how you see the problem and how you feel most comfortable attacking it. So in this case, we can say that 2.23 meters. We know according to our equivalent statement that 1 meter equals 1.094 yards. And if we put this into the calculator, 2.23 times 1.094, we end up with 2.44 yards as our correct answer. And you can see we've observed the correct number of sig figs because we start with 3 sig figs in the number 2.23. For the next one, we're starting with 292 centimeters. And then we're going to put centimeters on the bottom, inches on the top. We know that 2.54 centimeters is 1 inch. So when we put this number into our calculator, we get the number 114.96. We can see that there are 3 sig figs in the first number, so we need to round this to a number with 3 sig figs. That number is 115 inches. For the next one, we're using the same equivalent statement, just the inverse. So we're using a slightly different conversion factor. Here we're starting with 881.2 inches. We're putting 1 inch on the bottom, 2.54 centimeters on top. And when we put this into the calculator, we get the number 2,238.24. But our original number only has 4 sig figs, so rounding this number to 4 sig figs gives us 2,238, and our final unit here is centimeters. For the next one, starting with 1.043 kilometers, converting kilometers to miles means that 1 kilometer is 0.621 miles. Putting this into the calculator gives us 0.6482. That number already has the appropriate number of sig figs, so we just need a unit on that answer, and we have miles. And then in the last one, 0.501 feet is how many inches, and this is a good one to apply the does it make sense method, because we know that half a foot, or 0.5 feet, would be about 6 inches, so that's the answer we expect to get here. Starting with 0.501 feet, we can convert from feet to inches. We know that there are 12 inches in 1 foot. And multiplying this out, we get 6.01, which has the same number of sig figs as our original number. Final answer, or final unit, should be inches.